to participate in election? That's of course a very important question, and it has been addressed not only within economics, in many disciplines. It's one of the very fundamental questions of democracy. Let me make it smaller and smaller until you will see that I want to address a very specific aspect of that question. But let me narrow down the question here from this big one to a somewhat smaller question, namely the economics view or economists' view on this question. What motivates voters to participate in elections? Of course, there are many things you can say here. That you could feel an obligation to take part in democratic decision processes because you're a citizen. You feel that this is the citizen's duty, and there is certainly a truth in that. There is certainly also this aspect that economists tend to emphasize, namely, well, there is cost in voting, right? You rather stay at home, perhaps, do something nice with your family, read a book, have a coffee, and not go to vote. I mean, this is costly. If you want to take an informed decision, you even have to think about it, right? And think about the different party programs and so on and so on. So the very narrow answer of the economists is, well, since there are costs in participating in voting processes, if you want to participate, or if we see people participate, there must be a benefit in it. And there must be a personal benefit in it if we assume that people have selfish preferences, as most of classical economic theory has assumed. So here is the classical economist's account, mainstream economist's account of the question, namely, well, there is a trade-off between cost and benefit. And the expected benefit is, of course, the gain in utility times the probability of being pivotal, of making a difference with your vote. Now, probably you have heard, or I'm sure you have heard, about this so-called paradox of voting. Well, if this is really true, in large elections, the probability that your vote makes a difference tends to zero. I mean, is very close to zero. And so the personal gain must be very high, I mean, improbably high, in order to really motivate people to go to an election. So here is a kind of problem hidden in this pivotal voter model. And I want to hint at that. And this is, of course, the starting point and for a huge literature of formal pivotal voter models, of models about costly voting. And I'm listing here some of the literature, but I don't want to go too much into the literature. Actually, I should ask, how much time do I have? What is the time frame for the seminar? Is it okay?
One hour, including the questions. So you have something about 50 minutes.
Okay, very good. Yeah, very good. I will not need it, and we will be able to discuss. But nevertheless, let me not too much go to the literature. There are, of course, empirical tests of the pivotal voter model, and as always, the empirical tests show that there is a truth in the model, but one has to be careful about the context and to single out or to really concentrate on the aspects that are necessary and to exclude motivations that could go against this model. But my main point here in the talk is that all this literature, almost all the literature, both theoretical and empirical and experimental in particular, has considered two alternatives and majority voting. Okay, so it was always taken for granted that we do majority voting, and in order to do majority voting, you better restrict yourself to two alternatives, because as soon as you have more than two alternatives, it's not even clear what majority voting means. How do you do majority voting with more than two alternatives? That's, I mean, that's a topic for itself, and much of social choice theory is about exactly that question. So here is my particular question, or the question that we want to address with this project. whatever else may motivate voter to participate in multi-candidate elections, more than two candidates, does it matter which voting rule we use? That's my basic question. So this is the question that I would like to address. Can we somehow identify an impact on the voting rule that we are using for the participation of voters, right? For the participation decision of voters. That was at the beginning of our project here. And if we find that, which features of the rule are important? Now, multi-candidate elections, what are the usual voting rules that you can imagine? Well, as I said, in an abstract voting model, there are many possibilities. None of them is really what the best thing, or considered the best thing in general, right? I mean, it's always context dependent what kind of voting rule you should use. So we should talk about the context in which we want to address the question. And we want to even narrow down further the question, right? I mean, it was a big question with which I started, right? And now we are at a very narrow question, and I'm even narrowing it down further. Namely, here is a very simple model. We take voting on a one-dimensional variable, and we assume that preferences have a particular structure, namely are single-peaked. So let us assume now, from now on, a very specific context, namely, we have alternatives that can be ordered from left to right. And well, for instance, let's decide on the interest rate, right? The famous example that I will show you in 2 slides, or 1 slide, is the LIBOR. Well, the rules have changed how to determine the LIBOR, but until recently, the LIBOR, which is an interbank interest rate, was decided upon in the following way. The private banks submit a proposal. The most extreme proposals, I mean, there are, I think, 17 or 18 banks involved in this. There's a committee of 18 important European banks. I think it's a European interest rate, right, the LIBOR. So they all submit a proposal. In order to avoid strategic behavior, right, we'll come to that, the most extreme proposals are deleted and the average of the rest is taken. So this would be one context where you have a one-dimensional variable, the interest rate, the level of the interest rate. People have to decide on this by voting on it. And let's assume, for simplicity, but I think realistically so, that individuals have single peak preferences. So you have a most preferred value of this one-dimensional variable. And as you move away from this most preferred value, your utility decreases in an ordinal sense. So graphically, this means the following. Each individual, each voter, has a most preferred value. Let's call this the peak, Pi. Here is the voter 1 with peak P1. And the ordinal utility function, right? There's nothing cardinal here. Simply means that the further you move away from that value, the worse on both sides, right? It doesn't matter if you move to the right or to the left, you decrease utility, and the further you move away, the lower the utility is. But just in an ordinal sense, so you can take monotone transformations of the utility function. That does not change the fact that individual preferences are single peaked. I mean, I think most of you have heard of that concept of single peak preferences. So for voter 2, for instance, it looks like this. The peak is P2, and the utility function looks like this. For voter 3, like this. Okay, so this is the general picture. So the voters disagree on the best level of this variable, but they share this common structure that the further they are away from this most preferred outcome, the worst. So it can never happen that you have a local peak away from the global peak. That it means that is single peak preference. If you wish, this is really nothing uncommon here. It is simply convexity of your preference in an ordinal sense, right? I mean, if you have preferences over this one-dimensional variable, then single peakness just means that your upper contour sets are convex intervals in that sense. Yeah. All right. Please do interrupt me and ask me anytime you wish and I'm not clear. All right. I already mentioned this LIBOR, London Interbank Offered Rate, and until recently, and I tell you why only until recently and what has changed, this interest rate on which trillions of euro are traded, trillions, right? Trillions of euro are traded on this offered rate, and it was determined by 18 banks that could participate daily in a vote about the value of this interest rate. And as I already described, the participating banks would submit most preferred interest rate. I think 4 extreme to the upper part, the 4 extreme to the lower part would be deleted, and the mean value of the rest of the proposals would be taken as the interest rate of that day. Now, think a little bit about it, right? The mean, I mean, you trim, it's called a trimmed mean because you delete extreme values, and then you take the mean. If you're the manager of this bank, right, and what will you do? You know that the mean of the rest will be taken. So you engage in strategic consideration how you could manipulate in an optimal way the result of that election or voting process. And that's what banks did, and that's why they stopped doing it like this. But for many years, that was the method how this LIBOR was determined. Okay, they have changed it exactly because of the problem that I want to address later, namely that there will be strategic manipulation going on here. Another context, simply the question of funding public projects. Suppose you want to fund a public project. Let's say your faculty wants to decide how much money to spend on the academic guest program at Higher School of Economics. Now, you have 2 options, either to put the money into the guest program or to keep it for private salaries or whatever, right? Now, I suppose that different people of you may have different preferences about what would be the optimal amount to put into the academic guest program. But let's assume, realistically so, I would say, that your preferences are single peaked with respect to that question. Then you have an optimal allocation of money for the academic guest program, and the further you move away from that money, either too much or too little, would be worse for you personally. And then you would take a voting on the optimal compromise, how much money to put into the academic guest program. That would be one example. But of course, you can think of many other examples like this. There is a certain restriction. If you think about the problem, I mean, this is a very important problem. It's called participatory budgeting, right? So let people decide on how much money to spend on which purpose, on which public purpose. Do you want rather to build parks, or do you want to increase the health infrastructure? Do you want to, at the state level, do you want to have more expenditure on healthcare, defense, or infrastructure? These are I think, very realistic and important applications. The one restriction that is imposed here is that there are only 2 projects here, right? If you have this one-dimensionality, right, a one-dimensional variable means that you have more or less only 2 projects on which you can decide. Let's say there is a certain budget, you have to spend it, and you want to spend it either on one project or on another. But in reality, there are more than 2 projects. There are many projects, but that complicates the analysis a lot. So let's stick to this simple case. And in this simple case, these are the 2 most popular ways of deciding then. Either to take the mean of the votes. So VI is the vote of agent I. Then as this LIBOR is done, it doesn't take the mean of all votes, but after trimming the most extreme. Now, if you trim all but the middle vote, or the 2 middle, if it's an even number, then you call it the median, right? Because then you trim everything away, half of the, right? I mean, you trim away all votes that are extreme. So the only thing that is left is the middle vote if there is an odd number, or an even number, or the 2 middle votes if there is an even number. That's called the median rule. So these general class of trimmed mean has these 2 extreme cases, right? The full mean of all votes or the median of the votes. And actually, these 2 we want to examine now in this project. And the question now becomes, does it matter whether we use the mean or the median rule in this voting? And notice, the original question was about participation, right? It's not about the outcome. That the outcome is different for the 2 is clear. If you force people to participate and to vote, then of course something different will happen in the mean rule and in the median rule. And let's look at this. For simplicity now, assume that we take the outcomes, the alternatives, simply to be between 0 and 100. So this is a compact interval now of the reals that I'm focusing on. And these are the feasible alternatives. So you can vote for any value between 0 and 100. Assume for simplicity that no 2 voters have the same most preferred outcome. If you have a continuous interval, the probability for equal peaks is 0 anyway, under usual distribution assumption. So I think this is a weak assumption, and it simplifies our analysis a lot. And it does not really matter on this. So if you have 2 voters with the same peak, then yeah, you have to treat some special cases. So think now about this question. We are using the mean rule. You know that we are using the mean rule. Suppose we have complete information and it's simultaneous voting. So I know the peaks of my other fellow voters. They know my peak. Everything is complete information. We all know that the mean rule will be used. What is the equilibrium? Or what are the equilibria? Well, answer, there is a unique Nash equilibrium. And it works as follows. It depends on the distribution of peaks, but it is always at most 1 individual that does not vote extreme, right? So I'm saying that all but possibly 1 individual will either go to voting for 0 or for 100, right? What is the intuition? Well, if there's complete information, I can compute the mean of the true peaks. If I find that my most preferred point is below the mean, I should go to 0 and pull the result down. If I am above the mean, I should go to 100 and pull the result up a lot. There is 1 exceptional case. Now let me illustrate this. Suppose the peaks are this. First voter has peak at 10, the second voter at 20, and the third at 80, right? So they know that the mean rule will be used in the voting. So they ask, what vote should I submit? The answer is the first voter will vote for 0, the second voter will vote for 0, and the third voter will vote for 100. Why is this the unique equilibrium? Well, answer, if they do so, then the mean will be, of course, 1/3 of 100, which is 33.33. Now you see that the true peak of the two first voters is below 33 if they vote already as far left as they can, namely 0. And if the other one votes 100, then his peak, her peak, will be above the value, above the mean. So they are playing a best response to each other. And this is the unique way of playing a best response to each other. Okay, so you see two voters go to 0, one goes to 100. Nobody doesn't vote non-extreme. But we can alter the case. Here is the next scenario. Suppose we move the second voter from 20 to 40. So now the distribution of voters is at 10. First voter prefers a value of 10. Second voter prefers a value of 40. And the third a value of 80. What will happen? Well, again, the first voter will go to 0 and the third voter will go to 100. But what now about the second voter? The second voter sees, wait a minute, I am very close to the mean now, which would be 50. Can't I perhaps control, well, without him, the mean would be 50, right? Can perhaps I control the thing so that I get exactly my peak? And the answer is yes. The second voter goes to 20. And now what is the mean of 0, 20, and 100? Well, this is 120 divided by 3 makes 40. And the second voter is happy. But there can be only one voter who is happy, because notice our assumption was they have different peaks. So there can be at most one happy voter in the sense that this voter gets exactly her peak. So all the others do not get their peak, which means that in the optimal response, they must go to the extremes. There is no other way, right? Because if you don't get your peak, it cannot be that you vote in the interior, because you would want to pull the vote further to your peak, and that you can always do under the mean rule. Was that clear? I mean, that's the complete analysis of the Nash equilibrium under the mean rule. All but possibly one voter will vote extreme, either 0 or 100. There is at most one voter who, by controlling the result cleverly, can get her peak, but notice not by voting truthfully. So here in this example, nobody votes truthfully, and that will be the general case. All right, how about the median rule? Well, the median rule, it is well known, works completely different. With an odd number, there is a weakly dominant strategy here, namely tell the truth. That is the famous median voter theorem. It is a strategy-proof rule. If there is an odd number of individuals, right, it is a weakly dominant strategy to simply submit your true valuation. Why? Well, because if you're above the median, right, you cannot do any, I mean, by lying to the same side of the median, you will not change the result. So you can only change the median position by moving across the median to the other side, right, where your true peak is not, right, by lying. But you don't want to do that because your preference is singly peaked, because that risks that the median moves even further away from you. So in other words, under the median rule, there is no way of manipulating and pulling the result closer in your direction, right? So that's a famous result, there is a small remark here. I'm not saying that this is the only Nash equilibrium, right? Telling the truth is a weakly dominant strategy. In particular, it is a Nash equilibrium, but there are also other Nash equilibria, actually strange Nash equilibria. For instance, if we all say 15.2, right? And we are more than 2 people, and we all say 15.2. Then this is a Nash equilibrium. Why? Well, because there are 3 people saying 15.2 at least. So no single individual can change the result because, right, because the median will stay with 50, right? But this is somehow strange. I mean, this one should exclude. And there are refinements that you can address. Coalition proofness, for instance, would work. And then telling the truth is actually the only Nash equilibrium. So let me just very briefly, I mean, I think you got the point, right? With 3 individuals, the coalition proof Nash equilibrium, or the equilibrium in weakly dominant strategy, is to tell the truth. So the middle person, the middle voter 2 will get per peak 20 here in this case. There has been some questions about, do real voters, we are still not at the participation question, but I still have a little bit time, but I will rush a little bit through that here. There has been investigations whether real voters behave according to these theoretical predictions that I just described. And in fact, it's interesting, I myself have done lab experiments on this question, and it's actually interesting how well people recognize under the mean rule that they can manipulate, and they manipulate actually exactly like theory would predict them. They go to the extremes. I mean, they understand very well, well, after some trials, wait a minute, if I am above the mean, I should exaggerate. They do not exaggerate immediately as much as possible, which would be the equilibrium, but they recognize very clearly that there is something to manipulate here in under the mean rule. And okay, let me skip this a bit. If you have questions, I'm happy to answer later. But now let's come back to the question: what does all this apply for participation decisions, theoretically and empirically? Now, please do think yourself a little bit about it. I mean, if you were asked to participate in a voting, let's say determining the money for the academic guest program, could be in Heidelberg also an interesting problem. I don't know. I mean, in the moment, it's cheap to have guests, right? Which is good. All right, but suppose there are some costs in participating. Would it make a difference for you if we would decide according to the mean rule or to the median rule? Think a little bit about it. I mean, of course, even if we know that, yes, under the mean rule, people will manipulate, under the median rule, people will tell the truth, even if we all know that, suppose it's all common knowledge here, under what of the 2 rules would you rather stay home? Okay, there has been one paper in the AER by Osborne and colleagues about this question, and they claim, I mean, they have more or less exactly the model that I presented you. And what they claim is that more extreme voters are more likely to participate. I mean, they do not make a global statement about how likely it is to participate. They make a comparative statistics result that more extreme voters are more likely to participate independently of the rule, actually. That's what they say, which I find very surprising. They claim that there will be a silent middle, right? Because no matter what rule you use, more or less, I mean, I'm now it's very abbreviated account of what they say, but it's more or less like, if you can expect that the result will be anyway close to what you prefer, you rather stay at home. But if you're extreme, then you think you could influence the result more, so you participate. I mean, there is some, I mean, it has some intuitive, I don't know, appeal, but it is very deceptive, actually. And if you think more carefully about it, and if you concentrate on the question, mean versus median, here is what you come up perhaps with. Under the mean rule, you have a constant and sure, you have a certain impact, namely 100 divided by n, the number of voters, or let's say the number of participants, right? If we simultaneously decide about participation, then I know if there are n others that participate, I can impact the result either by voting 0 or 100, And the difference that I can make there maximally would be 100 divided by n. So only those voters who are really very close to the expected outcome have a direct incentive to abstain. All others will have a direct incentive to participate because they change the result. They can change the result a little bit depending on the cost, right? And that's of course now the question. Under the median rule, on the other hand, there is a necessary switch in your consideration, should I participate or not, between what happens in an odd numbered situation and an even number situation, right? Because either it is odd when you participate or it is odd when you don't participate. So since Osborne and colleagues in this paper never thought about the difference between odd and even, they could not possibly come up with all the effects that are important here. And the big question is, what do you use as median rule when there is an even number of participants? So if you do what is, I think, the most widely used method here, namely taking the lower, so with an even number of individuals, there are two middle values, right? If you take the average of the two middle values, you introduce a mini average rule, right? A mini mean rule again. And of course, you open up the possibilities for manipulation in the two middle medians, okay? So things get a little bit complicated here. And actually, you can prove interesting results. I don't want to talk too much about this proposition because I want to come to the main part. So please, I want to skip this. And I want to tell you, if you now even introduce incomplete information or so, the theoretical results on all this gets extremely messy, right? Because you have multiple equilibria. You have cases without equilibria, and you have, for instance, the following result with complete information and positive costs. You can prove that the only equilibria with an odd number of participants have a single participant under the median rule, and if you have an even number of participants, then the outcome will always be 50, no matter how the peaks are distributed, and results like that. So really there much happens theoretically. So the comparison is really difficult. Nothing unambiguous can be said. So that's when the experimental side in my mind always shows up and says, okay, so if theory is so difficult to do, what should we expect empirically? And even in the lab, it depends very much on the precise design that you choose here, in which order you let people decide. So what we decided, and now let me skip all this here, sorry. I discussed this with my PhD students, and we decided, let's do a field experiment. And our hypothesis was that individuals, instead of computing Nash equilibria, coalition-proof Nash equilibria under complete information, or Bayesian Nash equilibria under incomplete information, what they do is they simply use simple rules of thumb. And that was our hypothesis. They asked themselves, for instance, such a question, right? What is my maximal impact that I can have by participating in an election, either under the mean rule or under the median rule? I already told you the important observation is, under the mean rule, you have a certain but small impact, right? You can always influence the result by participating. If there are many others, of course, your influence will be small, but it is always greater than zero. For sure, it is greater than zero. On the other hand, if you have the median rule, then if you're not the median, you don't have an influence, or rather, well, you do have an influence, but only in the wrong direction, right? You cannot pull the result to your side. So I thought, well, personally, by introspection, I thought, well, I would rather want to participate under the mean rule, because then I know I can do at least something. Whereas under the median rule, the probability that I am the median is very low when the group size is, well, let's say reasonably large. So under the median rule, there's no point in participating, because I mean, yes, if only if I'm the median, I will be able to influence with the results. So that was my original intuition. And then came my clever student and said, no, that's not true. It depends on your beliefs about the peaks of the others, okay? If you believe that there is a bimodal distribution with the modes on the extremes, then in fact, under the mean rule, your expected influence is smaller. Why? Because when you are the median, you have a huge influence, right? You can perhaps change the result from something very small to something very large, okay? Whereas if you're, right? Whereas under the mean rule, it doesn't depend on your belief. It doesn't depend on the distribution. You have the same impact always. On the other hand, if the distribution is like a normal distribution, then under the mean rule, you have a larger impact. And he computed everything very wonderfully. And he showed that, okay, if you have a uniform belief, then the expected impact is the same under the median and under the mean rule. And then I was a bit surprised. And then I said, okay, but I am ambiguity averse. And that's why I'm so glad that Jürgen is listening here. If I'm ambiguity averse, then I would, of course, prefer to have a small but certain impact over this uncertainty about my impact that comes from the beliefs. All right, so time for an experiment. Here is the field experiment. And now comes the problematic part of the research. I mean, I will anticipate for you that the field experiment was a null experiment, unfortunately, right? We had hypotheses and we could not confirm any of our hypotheses. It's not that we found the opposite. It's simply we have results without statistical significance. And that is the unfortunate part of this project. So I'm still enthusiastic about the project, but the results from the field experiment were a bit disappointing. So here is the field experiment. We let students decide. We gave them real money. Actually, this was a quite expensive experiment. We gave students real money. We allocated them to groups of 17 subjects. So everyone knew that she was in a group with 16 other subjects. They would vote about the allocation of €100 either to the bike shop on campus or the campus garden. And they could really allocate the €100. So you see, you can, with 30 groups, €100, that was a quite expensive experiment. But you know, KIT benefited from the experiment, and now, of course, the bike shop and the campus garden are in good shape thanks to this experiment. So the treatment variable was the voting rule. Some groups got the mean rule, and the other, well, 15 groups got the mean rule as the voting mechanism, and others the median. They we sent an email to them. You are in a group. You can decide with 16 others. You can decide on the €100, and half of the individuals got an email saying you would do it by the mean rule and the other by the median rule. Here were our hypotheses. First, the belief about the impact is higher under the mean rule as compared to the median rule. But that was actually it was my hypothesis, and I am to be blamed for the result that we didn't find that to be true. Participants are more risk averse in mean voting as compared to median voting, this selection effect, right? So the hypothesis was whoever participates now is also partly, at least, affected by the risk aversion of the individuals. So if you are risk averse, you would not risk the situation in which you have no impact, but rather go for the sure. I mean, perhaps risk aversion would not be the right word here. It's really ambiguity averse, but that we wanted to avoid, I mean, as a term. Perhaps there is something here, and we should really rather say ambiguity averse and do some experimental measurement of ambiguity aversion here. But we didn't do that. The actual number of participants I was hoping was higher under the mean rule as under the median rule, right? Which is related to this so-called certainty effect in individual decision theory. And the variance of participants' votes is higher under the mean rule as compared to the median rule. Okay, now, why that? Well, because these are the theoretical predictions, right? I mean, under the mean rule, you go to the extremes. So you should expect that the variance of votes under the mean rule would be higher. All right, so we did not find any of the hypotheses. And the problem is not that we found the opposite. No, we simply didn't find statistical significance. So the belief there, you really do not see anything. When it comes to hypothesis 2, actually here we have something that I find, let me go to this. If you look at the results, it is in fact that the average under the mean rule is higher, right? You have more participants in total, and the group average under the mean rule is higher, 4.9 as compared to 4.2, actually out of 17 on average. But this is usual. I mean, this is not surprising. I mean, if you say, wait a minute, there were groups of 17 individuals and on average only 5 or between 4 and 5 really voted, but that's usual. I mean that's not the surprising part. I was hoping that under the mean rule, you would have more participants. That was my initial intuition, and it is still my intuition. I mean, and perhaps the reason is that it is still my intuition is I find the mean rule is simpler to understand, right? And I now believe that people would would rather participate in the mean rule, perhaps even only they understand what's going on. Whereas under the median rule, some people at least will not understand what's going on. But that couldn't go in both directions either. So anyway, what I want to really show you is that you need to have very good hypotheses when you start an experiment, and to think very carefully about your hypothesis, because they influence then the design of the experiment. And we have too little control here in this experiment over the motivation of the individuals. That's the problematic part of this experiment, is really we cannot really deduce much about the motivation of individuals. So since we did not get a confirmation of our hypothesis, we are really a little bit, we don't know really what's going on, and that's the problem here. We don't know how to interpret the results. So let me show you. I mean, this is age 4. The variance of participants is higher. Also, this we do not find any statistical significance here. Could of course be that we have too little observations, but I doubt that. I doubt that actually. So, all right, that's it. That's what I wanted to show you, and as you can see, this is an ongoing project, and we don't have conclusive evidence so far. What we are doing now is we actually do go to the lab and give them a much more structured exercise of participation, and we hope that we will find something there when we can control better about their motivation to participate and not to participate. But let me just stop here and take the discussion. So really, to summarize, it is more difficult than we thought in the beginning, and it's more complex. And we were not able to really reduce the complexity sufficiently in order to derive at good conclusions from the data of the experiment. And that I wanted to show to you.
Thank you very much, Clemens. I would like to take questions from the audience before I start asking my own question. If just to kick off, because it's very interesting. I think it's very. Also, thank you for the nice introduction into the topic by explaining what are the main problems and the main differences between the mean voting and the median voting. About the experimental design, if you could highlight, how did you choose, for example, the number 17? It's not a straightforward number that would. So why it is 17? And also what as an experimenter I would be interested in, you say there are more risk, well, this is how I interpret you said more risk averse subjects, more in the sense of the number of risk averse subjects was higher, right, in the mean voting group, because not the risk aversion of each subject was higher. So the question is, how did you measure that? Did you ask them to fill out the survey? So it appears to me you just didn't think about ambiguity aversion in the very beginning. So that's why you don't have the data on ambiguity aversion. Your mic is off. Your mic is off. Clemens, you're muted. Clemens, you're muted.
But I did not mute myself. You okay? Anyway, now you hear me. No, I muted myself. Okay, sorry.
Yeah.
Okay, 3 very good questions. First question, why the number 17? Okay, that was simply a trade-off between 2 things, right? I mean, in order to induce the doubt that you can make a difference, you should not take a too small a number, right? I mean, under the median rule, if we take very low number, then of course the probability that you are the median is not so low. So we thought that we need a larger group, which is also more realistic, right? If you think of participatory budgeting, right? You're not taking decisions in groups of 5 or 10 or so, but I mean, communities take participatory budgeting decisions, but we didn't want to take a too large, I mean, it was just a compromise here between realism, which would probably have required even not larger number, and tractability. So we came up with 17. Of course, an odd number, right? We wanted to have an odd number. So therefore, it was
not the 18 like in LIBOR voting. Because you mentioned
yes, why not 18? Exactly. Well, because 18 is an even number, right? Now you may say that doesn't make much of a difference, right? If only
it makes it, because if you tell all subjects still face uncertainty, if I understand correctly, about the number of those who will take part in the voting. Sure. Actually. So there is still uncertainty about odd and even number. So
that's right. You're completely right. I mean, yes, 17 was just, I mean, it was a compromise between different considerations. Then about risk aversion, that's very simple. We asked them to fill out this standard, I think Eckel-Grossman test, right? So we tested their degree of risk aversion, and we wanted to know whether, actually it is like, we wanted to know whether the average risk aversion was higher under the mean rule than under the median rule. And our hypothesis was it would be higher under the mean rule, right? Because of the selection effect, that if you take part in the mean rule, the reason could be because you're risk averse, right? So that would be an indirect confirmation of the hypothesis that risk aversion could induce people to take part under the mean rule, but not under the median rule. So our hypothesis was that for a fixed level of risk aversion, the probability that you would take part in the mean rule would be larger, right? That was the hypothesis.
But I wanted to ask, well, whether everyone filled in the questionnaire or only those who actually took part in the voting. So everyone who received email or only those who voted?
There were no individuals, actually. I mean, those individuals who did not respond to the email, of course,
Right.
did not fill out the
okay, so we don't know anything about that.
Yes, we don't know anything about the non-participants. It was only a comparison about the participants under the mean rule versus the participants under the median rule, right? We did not know. We don't have we don't have any information about those who did not participate.
Okay.
Right. Then finally about ambiguity aversion. Okay, so my honest answer is I wouldn't have known how to test ambiguity aversion. Or yes, I mean, I could have called Jürgen, of course, which would have been an easy way to find out. But I thought that it will not be necessary. But perhaps this is something that we should do.
Yeah. In the lab, yes.
Yeah, I think we should talk about that. I think it's not the aversion, I guess. It's what are you ambiguous about? I think from the experiment, it's not so clear. You framed, of course, your hypothesis in terms of what you called your impact factor.
Yes, yes.
I doubt that people look at this as something they're ambiguous about. Okay. They don't probably break it up in an impact factor. I think in these voting games, you want to predict a little bit the behavior or the average behavior of the others.
That's an interesting point. I mean,
so it's more about what are you ambiguous. Yeah, yeah.
Yes.
Yeah. Clemens, there are a couple of questions in the chat.
Please.
How students were selected and why these projects, particularly these projects, were chosen?
Okay, I mean, these projects, well, we had to think about projects that we assumed would be interesting to students. I mean, we wanted to have the highest motivation possible to take part in that. So what we thought is, what are the most popular projects, public projects for students that KIT funds, right? I mean, so that we can get the money more easily. I mean, there's always this pragmatic point of view. Where do you get the money from in order to finance your experiments? So what we thought is, if we want to really spend that much money, right, and 3,000 is a lot for an experiment, we need to somehow make everybody benefit from it, not only us as researchers, but also the students and KIT. So therefore, we searched for the projects that are funded from KIT for the students, and we found these, and or we found a number of them, and among these were the two most popular.
Yeah. And then there is also a guess from Maria also. The question was from Maria, and she guessed also that maybe the students were not so interested in bikes in the garden. So you'd better explain the meaning of a bike for a German student.
Ah, okay. Now a bike. All right. That's of course a very interesting question. So going by bike is very important. I mean, in the summer term, the campus is full of bikes, and they break from some time to time. So, and when they break while you're on campus and you don't know how to get back home, right? You're so grateful if there is a bike shop that can help you instantly fixing the problem with your bike. So that's why students are interested in the bikes. And the garden, of course, I mean, ecological gardening is very popular. Note that was before the pandemic. And from the perspective of now, ecological gardening seems not to have that value that it used to have 2 years ago. But it was very popular, this gardening workshop for students. They could attend it for free, right? That's also the important thing here.
But the thing is also that they could choose, even whether it was important or not important, they could choose between the two. And you were interested in finding the difference between the two different voting modes, yes, rather than yes, between their preferences.
That's right. The hope was that if a student would be at least interested in one of the two,
yes,
right, he would have a motivation to take part in the voting. That's
And bikes are very important in Germany generally, and in German universities, bikes are extremely important. Many professors come to job by bike. Jürgen was always coming by bike to work. You're muted, Jürgen, you're muted.
Yes, I did. But I didn't have to go too far, you know, so the shop was not, or the repair shop was not the problem.
Well, well, we were on a different campus. If it was Neuenheim, there are more students,
Right,
more bikes there. So bikes are really, really, really important. And in Karlsruhe, they're even more probably.
Yeah, of course.
Yeah.
But let me further, this is a good question, but there are not so many possibilities of using money on the student side. Of course, we could have said, we fund with that money a better food in the Mensa or something like this. But I mean, this would be a drop. I mean, this would be
not
a
noticeable.
drop on the hot stone, as we say, right? I mean, it would not really make a difference for the students. So actually, I'm pretty satisfied with our choice of projects. That is the one part of our experiment that I still like a lot, and I would choose exactly the same projects if I would do it again, right? But I would probably do the emailing, the selection differently. How the students were selected simply from our base of the students. We have an experimental database of students who agree to take part in experiments. These are mostly lab experiments, but we thought that if we write to them the willingness to participate a priori, right, in this thing would be greatest for them. And still only 4 to 5 participated, right?
We are already, well, 1 hour of seminar. We need to conclude. Just wanted to say that maybe it might be interesting also to explore the opportunities to do a similar experiment on the Perm campus and to explore cultural differences, because whether students differently perceive the voting per se, and the need to vote in order to contribute to a decision and so on. So that could be something that many of the participants of today's seminar may think, and which projects we would choose on the Perm campus, because bikes probably in Perm would not work.
Well, please, I mean, I mean, it would be wonderful if you would do that, if we would do that together. So please think about good projects and where to get the money from.
Our money is everywhere.
No,
yeah, Thank you very much, Clemens. Thank you very much to everyone, to the participants of today's seminar. I should announce that our next and only seminar this term will take place on the 17th of May, because the beginning of May is a public holiday in Russia. And actually, well, it is public holiday until the 10th of May included. So it's there are 10 days of no work. At least no university work in Russia. So the next seminar is the 17th, and I think on the 24th, it doesn't really make sense because this is the very end of the term and the exams are starting. So I think that we will skip that last day in May.
And on the 17th, who will present?
17th of May, Luca. A good friend of mine, but I just forgot the name.
Okay. Well, you know the name. He's called Luca.
I know. I'm afraid to wrongly pronounce it. Luca Corazzini from the University of Venice, and he will be talking about the narratives that are used in newspapers during the pandemic, so COVID-19 pandemic, and how the narratives used in newspapers influenced the decisions and behaviors of consumers, I think, in that direction. So that's good. It's a very recent project, as you can guess, and I believe that it will be quite interesting to see how narratives used in the newspapers contributed to polarization of opinions. I think in Germany, this is a particular issue. So that could be, and in Russia as well. So that I'm looking forward to that talk. 17th of May, the same time, we will send around the link.
All right. So thank you very much. Thanks for your attention.
Thank you very much to everyone, and have a very good day, and see you in, and have great holidays in Russia.
Just back to work.
Okay, bye-bye.
Bye-bye.
Bye-bye.